Okay, for what we have in continuing on with determinants, and we have with special kinds of row operations to potentially make the um, configuration of the determinant, especially for larger square matrices, a little bit quicker. We have for row operations, and we have, say, for square matrix A, we have these rules of thumb, and we'll look at what we have, especially in part A. It says let A be a square matrix, and it says that if a multiple of one row of A is added to another row to produce a matrix B, then the determinant of that formed matrix B is equal to the determinant of the original matrix A. And just thing to keep in mind, do not multiply or divide a row only. And I'll get into details in just a moment. And what you're going to be looking at is that for this particular scenario, the object is going to be to produce a triangular formation of zeros. And let's say that now from the previous lesson, okay, say if you're looking at the determinant matrix A. So again, we have first row to consist of 1, 2, 3, second row 0, 1, 4, negative 2, 0, 7. Now we looked at the determinant of that particular matrix before doing any, without doing any row operations, but to get to where we have a triangular array of zeros. Okay, so getting to what we have in echelon form. Okay, so you have for the first column we have 1 and 0. And if we make the negative 2 into a 0, okay, so we have underneath the 1 we want a couple of zeros. So to convert this negative 2 to a 0, I can go through the process of taking the third row elements and adding 2 times the first row elements. So the third row becomes 0, 4, and 13. And if you notice, okay, we have, again, the first pivot position, we have to be in the upper left-hand corner. And going diagonally, okay, we have for the second pivot position, that is the next one. And underneath, okay, we have the number 4. And I want to make this 4 into a 0. If you notice, okay, if I have the 4 as a 0, and we have a triangular formation with 0, 0, and 0. And to convert the 4 to a 0, working with the pivot value 1, we have taken the third row. I'm going to take away 4 times the second row. And so for what we will have here, the bottom row becomes 0, 0, and negative 3. Okay, and if you notice, you have this particular triangular formation of zeros. And so upon converting this matrix A into echelon form, where we had the triangular formation of zeros, I can go through the process, okay, where we have 1 times the determinant of, again, like the cover up, the same row and the same column values. Okay, I have exposed 1, 4, 0, negative 3. And again, I have minus 2 times the determinant. And once I cover up the top row and the middle column values, I have exposed what would be the determinant of 0, 4, 0, negative 3. And we have plus 3 times the determinant. Okay, so covering up 3, I have exposed 0, 1, 0, and 0. And so for what we will have in the process, okay, so it is going to follow that for what we have here. Okay, so we have you have the first case for the determinant of A. So we have 1 times, in case you have negative 3, minus 0, so you have 1 times negative 3, and I have minus 2, and I have, so got, you know, so have 0 times negative 3 is 0, 0 times 4 is 0, so this will become negligible, and guess what, we have with the next determinant have 0 minus 0, and so for what's going to happen here is that for the determinant of A, once again, we're going to have the value of negative 3. All right, now, looking at what we had also encountered from the previous lesson, we have with our 4x4 matrix, again, we have the elements. We have at the top, okay, we have 1, 2, 3, negative 1 forming the first row. Second row, we have 0, 1, 4, 1. Third row, we have 1, 0, 2, negative 1. And the last row we have 3, negative 1, negative 2, and 0. And to get this into echelon form, I want to make the digits underneath the 1 in the first column, make them all 0. So in working with the third column, going from 1 to 0, I'm going to take the third row and deduct all the elements from that correspond in the first row. And with the last row going from 3 to 0, I'm going to take from the fourth column elements. I'm going to take away 3 times the first row elements. Okay, so third row becomes 0, -2, -1, 0. Last row becomes 0, -7, -11, and 3. So I have 3 zeros. And if you notice, we have first pivot position is in the upper left-hand corner at 1. Next pivot position, we have the one that follows in the second column. And for the numbers underneath, again, I want to form a triangular array of zeros. So I want to convert the -2 and the -7 into zeros. Okay, so to go from -2 to 0 and -7 to 0, we have third row plus 2 times the second row elements, and then we have for the last row, okay, and that should be in this case where we're going to have the fourth row plus 7 times, okay, the second row elements. Actually, that should be an R4. Okay, so you have taking 7 times the second row elements. So we have 0, 0, 17, 10 for the last row. Again, we have for the third row, this becomes 0, 0, 7, and 17. And again, to get to where we're going to have a diagonal array of zeros, or triangular array of zeros. See, I want to make this 17 into a 0. Now, when we looked into reduced row or reduced echelon form, we had converted like the 7 into a 1. But for what we have in the case of row operations and determinants, we're not going to take fractions or multiply or divide by, in other words, we're not going to multiply or divide alone. Okay, so do not take 1/7 of the third row. What you're going to do is that you can keep what we have. We're going to keep what we have in the third row by itself. And so if we put what we have in echelon form, okay, and make this 17 into a 0, what we'll do here is I'm going to make the 7 into a 17, so I'm going to say, or -17, so we have R4 minus 17/7 of the third row elements. So for what we're going to have to arise, okay, so we're going to have 17 minus 17/7 of 7, so it'll be 17 minus 17, which will be 0, and 17/7 times 2, okay, that would be 34/7, and if that is deducted from 10 being 70 over 7, we have the difference will be at 36/7. And if you notice, we have this particular triangular array of zeros. And in looking at what we have and forming what we have with the determinants on the basis of the adjusted matrix A after the operation, so we're going to have 1 times the determinant, and again, so we have exposed 141, 072, 00, 36/7. Then we'll have -2, you have times the determinant, 041, 072, 00, 36/7. And then we have +3 times the determinant. So if I cover the top row and the third column values, and we have exposed, okay, what will be the determinant of 011, 002, 00, 36/7. And then we have minus -1. Okay, you have times the determinant. So you have 014, 007, and 000, and just running it through the mill. Okay, so you have 1 times. Okay, so you have 1 times the determinant, and the exposed elements in the 2x2 formation have 720, 36/7, minus 4 times the determinant, 020, 36/7, and we have +1 times the determinant, 0700, and we have -2, and just running what we have for 0, 4, and 1. Then we have +3, and running through what we have with 0, -1, and +1. And then we have +1, and you have just running what we have here is 0 times the determinant, 0700, minus 1 times the determinant. Okay, we have 0700, and you have +4 times the determinant, 000, and 0. Now there will be a lot of expressions that will be negligible. Okay, so you have in this layout, okay, so you have 2x2 determinant. Here, this will go to 0. Diagonal products also at 0. And you have 0 times the determinant, Okay, that goes to 0. Diagonals here go to 0. Another set of zeros. We got 0. Diagonal here is 0. Another 0. Got 0 minus 0 is still at 0. And the only thing that is left standing is what we have with the first determinant. Okay, so you have 7 times 36 sevenths. So this will go to 36. And we have 1 times 36. And so for what we're going to have in the ultimate outcome, we're going to have at 36.